This is for chapter 9, Coursebook 9. 9.1 is talking about simplifying algebraic expressions. So expressions are given in terms of unknowns. So there are a few things that we need to learn here about the law of indices. So the law of indices is that if there is a power, what do we do with it? Especially when we multiply or when we divide. So for instance, if I say x to the power of 3 multiplied by x to the power of 2, the answer is x to the power of 3 plus 2, which in turn x to the power of 5. This seems to be very easy to understand. This is when we do multiplication. And then when we do division, however, it is just a subtraction. So x cubed divided by x squared is equals to x3 minus 2 is equals to x to the power of 1. We can write x to the power of 1, or you can just leave it as it is. This is for division. So as you can see, every time when we divide, we minus. Every time we multiply, we add. Well, what's the reason behind it? So let's just look into it a little bit more. So x cubed times x squared. Let me just change them into a different color so that I can show you what actually happens. So x cubed will look like this. Okay, the multiplication sign, I'm just going to put it here. Just going to equate it at the bottom here, x times x times x. This is x cubed. And then x squared is like that as well. So as you can see, there are a total of 1, 2, 3, 4, 5x. And then we can just equate them as x to the power of 5 immediately. Okay, so this is the underlying concept behind it. Okay, so the next one would be division. And then if you look at division, it's actually written in terms of, if you want to think about it, you can think of it in terms of fractions. So what actually happens is when it's x divided by x squared, it's actually written this way. Well, if this is not clear enough, let's just break it down a little bit more. X cubed. So if you remember, when we are simplifying fractions, you can actually see they have things in common. These are what we call common factors, because they're all times x and times x, they're common, so I can actually cancel them. Same thing here, I can cancel that, and what's left is just this 1x remaining, so I can just write x. So in case there are bigger numbers that you're worried about, let's say x cubed, x to the power of 5 divided by x to the power of 2, then you can just write it out if you want to. If you don't want to, you can also just leave it as it is, divided by x squared. You can just cancel them. And you can count how many x's, 1, 2, 3. So I can just write x cubed. Okay, this is one thing that you need to remember. However, let's just do a quick recap on when we add and subtract. You need to make sure that they are the same unknown. So for example, 2a minus a is equals to a. Can 2a squared minus a, you cannot do anything because they are two different things here. You have to leave it as it is, and this is actually the final answer. So if you have this, it is the same thing. You cannot do anything because they are of different level or they're different power. You cannot do anything to it unless they have the same power. A to the power of 5 plus 7a to the power of 5, then yes, you can write 8a to the power of 5 because they have the same power. Okay, this is just a quick recap. Addition and subtraction, they must be the same power, then you can solve it. If they are not, then you cannot, you must leave it as it is. So for example, 3a plus 4a, you can get 7a. This is correct. But it is 3a squared plus 4a cubed. You cannot do anything to it, and then you just have to let it be. Well, the only thing that you can do is you can rearrange it according to the power if you want to. If you don't want to, it's fine as well. All right.